Some questions about how to conduct this lab, so I thought I would make a quick tutorial for you guys to do. Um, in this lab, you are asked to determine the epicenter of an earthquake in the San Francisco area and then also in Southern California. So there are two other locations that that are excuse me, available to you. I'm going to do one of those as a demonstration, and if you would like to do the remaining one, you can submit it to me by email with the information for 10 points of extra credit. So the first thing we need to do, it says to click on this website, Science Courseware Virtual Earthquake, and then go to the bottom, choose San Francisco area. So we're going to do that. And you really need to read through this because there's some information on here that you will need for your test. But I'm going to scroll down to the bottom. San Francisco's already chosen. That's one of your required ones to do, as is Southern California. So I'm going to choose the Mexico one. And then, as I said, if you would like to do the Japan one as an extra credit, you can email that information to me. So we'll click on Submit Choice. We've got 3 different locations, and we need to determine where in Mexico this earthquake has happened. The first thing that you need to do is look at the S&P intervals. You learned about S&P waves in the previous chapter. P waves are faster traveling. They can go through solids, liquids, and gases. The S waves travels more slowly, and it can only travel through liquids, or excuse me, not liquids, just through solids. However, if we can determine how much longer it takes for an S wave to arrive at a seismograph station, then we can figure out how far away the earthquake is. So we're going to look at 3 different seismograms. The first one, I'm going to make this a little bit bigger so we can look at this. The first one that is given is, I'm not even going to try to say the names of those states. Now, right here at time 0 is when the first P wave from the earthquake hit. And then it settles down, it jumps a little bit, and then it settles down. And then if we look right here at about time 62, 64, it's a little bit between the 64 second and the 66 second. So this is where the next jump occurs. The second jump is where that S wave hits. So we want to record what that time is. And so on this one, if we go down, each of those lines represents 2 seconds. We're in between the 4th and the 6th second after 60, so I'm going to put 65 seconds here. Move on to the next one, and again, right here at time 0, this is when the P wave hit. Jumps around for a while, then settles down, and then boom, another big hit. So now if we go down to this one, you find that the earthquake, this would be 42, this is 44, it's about halfway in between. So we're going to put 43 seconds. The third one, again, and I chose this one deliberately because the lines are pretty small and it's a little bit more difficult to read. But you can see right here, time 0, the P wave hits, settles down, and then right here again, the S wave hits. So at time 60, we're going to put 60 seconds. Now, so we know how long it's taken for the S wave to arrive after the P wave. Now we can use that information and a graph to figure out how far away from each of those stations the earthquake actually was. So we're going to use this chart, and again, it's important that you read through this because you will be tested on that information. So now, I'm going to make this a little bit smaller again. So here are those times that I put in on the previous page. So the first one, 65 seconds away. You'll notice over here we have time on the vertical axis, on the horizontal axis is distance. So we'll go up to 65. These are by seconds. And we're going to go across to where this intersects. Right here at this line, this is 640. kilometers away. It's slightly below that. So we're going to go at about 635 kilometers. The next one, 43 seconds. Here's 40, 1, 2, 3, move over. It's right here on this line. If we go down, 420 seconds. So we're not seconds, sorry, kilometers, 420. And then the last one is at 60. So we're going to go across. And you'll notice right here, this would be 580. This is 600. It's a little less than halfway. So probably maybe about 685, 690, somewhere around there. I'm going to put 690. So those are where I think my distances are. Now, what this is telling us and what seismographers can do is they can use that information. They locate where that seismograph station is at, and then they draw a circle around that station with the radius that represents that distance. So if you circle one, make one circle, all you really know is somewhere on that circle that you drew, that earthquake occurred. It doesn't tell you what direction. If you take information from a second station, those two circles that are drawn are going to intersect each other at 2 points. And now you've narrowed down the possible locations to 2 different points. If you add in a third location, that third circle will intersect one of those 2 points, and you know where the earthquakes occurred. So I'm going to click on Find Epicenter. I made a mistake on here somewhere. It says oops. So if we get an oops, then we need to go back. So I'm going to scroll down, remeasure my S&P intervals. I'm going to go back, check these again. That one looks good. This one looks good. And that one looks good. So I'm going to go back over to this chart again and try those distances again. 65 seconds. I have 635. Mazatlan at 43 seconds. 420. And at 6 seconds or 60 seconds, oh, there's my mistake. That shouldn't be 690. It should be 590. So I'm going to change that. Find the epicenter, and I get a very close. Now, you're going to get 3 different comments on here. The oops that you saw initially from my mistake, very close or excellent work. If you get very close or excellent work, then you can move on to the next part. The next part of this is to determine the strength of the earthquake, the Richter magnitude. We're going to move on to this. Compute the Richter magnitude. And what we're going to do now is, you may have noticed that these waves that occur are different heights. And so we're going to measure the height of those waves, and that's going to help us determine the Richter magnitude. So I'm going to scroll through. Again, very important that you read through this because you'll be tested on it. But I'm going to move these up. And I'm going to look at the S wave, and I'm going to measure the height of the tallest wave. So we're going to use these lines along the side this time to do that. And you'll notice that this one right here is above the first line, so that's 10. It's not quite to the next line, so it's not quite 20. So I'm going to put about 17. And I'm going to go to the next one. This one's a little bit easier to see. Here's our highest wave, right at 50 millimeters. And then the last one, right here, again, is going to be at about 10, a little bit more than that. So I'm going to put 15 for that one. So then, submit. And I've mismeasured something again. So all of these should intersect. So I'm going to go back. If you get this document expired, just keep hitting your back button to get to back to where you need to go. So we're going to move through this again and again. I'm going to make this even a little bit bigger. And again, the reason I chose to do this one is because of this, it's a little bit more difficult. So again, I'm going to stick with 17, I think, is what I put there originally. Move on to this one. My highest one is at 50 millimeters. And then this one, I'm going to go to 10. Try that again. I'm still measuring something off on here. I'm going to put this though, because I have the yellow and the green at about 6.1. So I'm going to try 6.1 for my epicenter. Confirm. Make this smaller again. So final tabulation. Now, you can do this if you want, but you can just record the information for me as well. And there's a possibility you can go to Get Certificate. It says I'm going to just click on that. If you would like to just save this information for me and attach that as a file when you do the one for Japan, if you decide to do that for extra credit, you can just email that to me. And so that's it for this little tutorial.